This is day 2 of Unit 3, Section 2. We're starting textbook section 3.2. So we've talked a lot about real numbers for your whole high school career, your whole math career. And there's actually something that's not a real number, and that's called an imaginary number. So we call the imaginary unit I, right? I for imaginary. And I is equivalent to the square root of -1. So all that time, anytime you got the square root of a negative, you wrote no real solution. And that was because the solution is imaginary. All right? So anytime we have the square root of a negative number, I can replace the square root of the negative with the letter I. A complex number has a real part and an imaginary part. So the standard form of a complex number is a plus bi. So a would represent the real part, and I would represent the imaginary part. There could be a number in front of the I or something else after the I, but the I part is the imaginary part. So if there is no number in front, it's just purely an imaginary number. But as soon as I have something to add to it, it becomes a complex number. So equivalent complex numbers are when the imaginary parts are equal and the real parts are equal. And I apologize, I just realized I said this is day 2. This is actually day 3 of Unit 3, Section 2. So now that we talked about equivalent complex numbers, matching up the real with the real, matching up the imaginary with the imaginary, that's what we can do. If I want to find the values of x and y that satisfy this equation, where a complex number equals another complex number, I'm going to take the part that's real with the part that's real and make an equation out of that. 2x equals 10. Right? And in that case, if I divide by 2, x is 5. And then I'm going to take the imaginary part with the imaginary part. So that's a negative 7i equals y times I. So if I divided both sides by I, right, cancels, we get negative 7 equals y. So you go ahead and try these two. You can pause it and then check your answers. All right, so for number 1, matching up real with real, we get x is 9, and imaginary with imaginary, we get y is negative 3. For number 2, real with real, we get x is negative 4.5, or negative 9 halves. And then for y, once I cancel out the i's, I was left with 4y equals 3, so divide by 4, y is 3/4, or 0.75. Something else we could do with complex numbers is we can add and subtract them. So if I want to add and subtract the complex numbers, I'm almost treating the I like it was a variable. So I'm going to look for like terms. So here, right, addition, so nothing happens to this set of parentheses. We have an 8 and a 5. So 8 plus 5 is 13. And then I have the imaginary components, negative I and positive 4i. So negative 1 plus 4 is positive 3. And this is standard form because the real part comes first and the imaginary part comes second. All right, let's look at this one. This is a negative, so that means I'm going to change every sign in this set. All right, now that's gone. So 7 and negative 3 is 4. Negative 6i and positive 6i becomes 0i, so I don't even have to write it. So the answer to that is just 4. And then this last one, just this set's going to change the signs. So now I have a 13 and a negative 2, so that's 11. I have a negative 7i and a positive 5i, so that's minus 2i. So go ahead and try these, pause it, and then you can check your answers. All right, number 3 was just straight up addition, so we end up with 3 plus 6i. Number 4 was subtraction, so we change the signs of the second set. We get negative 5 plus 9i. And the last one, both sets of parentheses would change because each one had a minus in front, so we end up with negative 10 minus 10i. We could also multiply complex numbers, and something special happens when we multiply I times I. So if we get I squared, I'm really looking at negative 1, or the square root of negative 1, squared. And if you recall, anytime I have the squared and the square root, they cancel each other out, so we get whatever was left inside. So I squared actually equals negative 1. So whenever I'm doing multiplication, if I end up with I squared in my answer, I want to turn that into negative 1 because I never want to have i's where I don't need them, right? If there's just a regular I in the problem, that's fine, but as soon as I have I squared, I want to get rid of it by turning it into negative 1. So let's multiply these complex numbers. So here, 4i is going to get distributed. Oh, don't know where that came from. So 4i times negative 6 is 4 times negative 6 is negative 24, and it drags along the I, plus 4i times I, so it's 4 times 1 is 4, and I times I is I squared. So we're going to turn this I squared into negative 1. So this is really negative 24i. 4 times negative 1 is minus 4. And we always want to write our answer in standard form. So the negative 4 has to come first, and then we have the negative 24i. So that's the hardest part about doing these problems, remembering that at the end, it has to be written in standard form. All right, let's look at B. 9 times negative 4 is negative 36. Get plus 63i. And negative 2i times negative 4 is plus 8i. And negative 2 times 7 is negative 14. I times I is I squared. So just like before, the I squared is going to turn into negative 1. So this term right here really turns into plus 14. So I have negative 36 plus 14 to get negative 22. And then 63i plus 8i to get plus 71i. My answer is written in standard form because the real part is first and the imaginary part is second. Go ahead, try these three, pause it, and then you can check your answers. All right, so for 6, negative 3 times 10 was negative 30, and I times I was I squared. So this turned into negative 30 times negative 1, or 30. Number 7, I times 8 was 8i, and I times negative I was negative I squared. So that became minus I squared, or minus negative 1, which is plus 1. So writing it in standard form, we had 1 plus 8i. And number 8, we distributed the 3, got 15 minus 3i. We distributed the I, got 5i minus I squared. This minus I squared again became minus negative 1, which is really a plus 1. So 15 plus 1 was 16. And negative 3i plus 5i was positive 2i. And that is the end of section 3, unit 3, section 2, day 3. This is the second part of 3.2.